All right, let's do some Mathity-Math. It says here, you are wearing your new rollerblades and have a, let's just say, a jetpack strapped to your back. Wow, what a dangerous choice. But hey, it's a word problem, we'll let it slide. It says you are blazing down the road and your path can be modeled using the equation y equals 0.8x plus 5. You look over to the side and you see a magic pot of gold that could disappear any second. Okay, the gold is located at G 15, 16, and you need to get there as fast as you can. Find the shortest distance from your path to the pot of gold. Okay, before we start this, I think it's important to go ahead and model this or draw a quick little sketch to help us see exactly what's going on here. Because our gold is in the first quadrant, I'm just going to actually kind of model only the first quadrant, though hypothetically this line would travel in other quadrants, but let's just focus on the first quadrant. Okay, so here we go. Okay, so we're just going to focus here on the first quadrant. So the first thing it says is we know the path we're on. So I'm going to go ahead and model this line. So I go to the y-intercept of 5, 1, 2, 3, 4, 5. And I got my slope 0.8. And now this might hang a couple of you up. But if you read this, if you think about it, it says my slope is 0.8. I can put it, where can we see it? If I can put it right here. It says my slope is 0.8. Well, if you think about this, if you read this, that reads 8/10. So you could write it like this, 8/10, and then you know for every 10, it goes over, it goes up 8, right? 8/10, 8/10. Okay, so I'm actually going to go over 10 and up 8 from this point. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and then I'm already at 5, but I'm going to go up 8 more, so that put me at 13. So 6, 7, 8, 9, 10, 11, 12, 13. So there we go. Remember, this is just like a sketch or a diagram, so it's okay if it's not completely perfect. It's just to help us see what's happening here. So this image reflects the path that my roller skating, jetpacking adventure is following. Okay, so I'm just zooming along on my rollerblades when I spot some gold. Okay, the gold is at 15, 16, 11, 12, 13, 14, 15. This was 13, 14, 15, 16. Okay, so the gold, let's see here if I can use this little contraption. So the gold's about here. Okay, so the gold is about here. Okay, and the gold is at 15, 16. Okay, so that is the gold. Now, I'll put a G. Ta-da, that's the gold. Okay, so what we want to think about here is that if there is a line, and there's a point that's not on the line, the quickest way or the fastest way to get there is actually to take a perpendicular route. So I use a different color pen here. So the shortest distance, and that's what they said, the shortest distance would actually be this perpendicular line right there. I'll draw a perpendicular symbol. There you go. So that perpendicular line right there, that would be it. And so there's a point here, this point here, that we don't know. Okay? And what we're going to try to find is the distance from this point that we don't know to 15, 16, and that would be the shortest distance. So that's going to be our answer. Now the question is, how do we get all that so that we can get the answer? Okay. All right. So looking down or looking back at this, we know this slope right here, and I just told you that it's going to follow a perpendicular path. So essentially, what we got to do is first we should try to find the equation for this perpendicular line, and we're going to use that equation then to help us find this point here. So this line right here is y equals, and I'm going to write it as a fraction, 8 over 10x plus 5. Okie dokie. Our perpendicular line is going to have the reciprocal opposite slope. So the reciprocal would be 10 over 8. Its opposite, so it'd be negative. And then we x plus, and we don't know, so we just write b. Okay. So now we have y equals negative 10 over 8x plus b. We want to find this b. but we need to plug in a y and an x. And this is why this g value is so important, because if you think about it, this g value is on the perpendicular line. Like if I extended this perpendicular line, you can see 15, 16 is on that perpendicular line. And that means because it's on this line, I can plug it in. So my y value is 16, negative 10 over 8, and then 15 for x plus b. Okay, and so at this point you're going to calculate, well, what is negative 10/8 times 15? And this is a good opportunity to go ahead and use your calculator. And why not? And sometimes we avoid using the calculator when we have a fraction, but you can use it. It works just fine, right? So I'm just going to put in parentheses, negative 10 divided by 8, close that parentheses. I'm going to open a new one, put in 15, and hit enter. And I get negative 18.75. So now I have 16 equals negative 18.75 plus b. So now I just need to add this to both sides, and I'll have b isolated. So I'm just going to say 16 plus 18.75. I get 34.75. So now I know b is 34.75. So I can plug this back here, and now I would know the equation of this red perpendicular line. And that equation is y equals negative 10 over 8x plus 34.75. And then at this point you might be saying, oh, well, that's all great and well and good, but how does that help me get this point? So this is how you have to kind of make this jump into a very interesting conceptual concept. You see, this point we're looking for, right there, that red point, that is where our first line, our rollerblade rocket path, intersects with our perpendicular line. And we have to remember, when two lines intersect, at that point, at this singular point, they are the same thing. They're existing simultaneously. And in math, when something is the same, we can set them equal. So all we're going to do here is we're going to take this equation up here and set it equal to this one right here. Because they are existing simultaneously, they're happening at the same time, they are equal, so we can set them equal. And this kind of goes into an interesting concept if you think about this. So we could say, well, y equals y, because they're the same thing. Well, that makes sense. And this up here says, no, well, y equals 0.8x plus 5. So I'm going to substitute out. So instead of y here, I'm going to write 0.8x plus 5 equal to y. Well, this says, whoa, well, y equals this right here. So I can, instead of y, substitute this. And what this does, it's important to understand the concept of, y equals y and things existing simultaneously and all that. But pragmatically speaking, or practically speaking, what this does for us, which is really great, is now we only have x's. See, we only have x's. The y's have disappeared, so we can solve for just one variable, okay? Okay, so now looking at this, we do have one of these unfortunate decimal fraction situations, which can be tricky, but you can also use your calculator to resolve this. We're going to get our x's on the left and our constants on the right. So if I want to add 10/8 to 0.8, right, you can do this on your calculator. I start with 0.8, right, that's this right here. And I'm just going to add to it 10 over 8. So I'm just going to put in parentheses and put 10 over 8, just like that. Oops, how about I let you see it? Just like that. Da-da-da, you get 2.05, okay? So now we have 2.05x, and now we got to subtract this 5 from both sides. So we say 34.75, that's this right here, and we're just going to subtract 5 from both sides, minus 5. 34.75 minus 5 is 29.75. So that gives us 29.75. Now, just to get x all alone, we just divide 29.75 by 2.05. So divided by 2.05. Oh boy. So we say that x is, let me let you guys see that little number here. X is 14.51219.512. Okay, so when I give my final answer, it's going to be to 3 sig figs. So I'm just going to go to 4 decimals for the working number. This is a working number, right? I'm working with this, so I want to go farther than I need so I don't try to affect my answer. Hypothetically, I should just put this whole thing in, but I think it'll be fine for today. All right, so here we go. This is the x value. This is this x value. Right? Oh, you can't see it. There we go. This x value is actually right here. That's that x value. Okay, so now we're going to take this x value that we just found, and we're going to plug it back in. And we can plug it back in to either our initial, this equation right here, or we can plug it back in up here. It doesn't matter. We're going to get the same y value. I'm going to choose this one up here just because it's a little bit of a smaller number. And actually, you can see here, what I can do here, I have this whole value right here. I know that I just need to multiply that x value by 0.8. So just to maintain accuracy in my work, I can just say times 0.8 and then add 5. And here is my y value. And I can say, well, then my y value, let's come back down for you. My y value is, let's say 16 point, and we'll just go 6098. Okay, and to reiterate here, when I give my final answer, I'm going to 3 sig figs. That's what I'm doing here. So I've gone out to 4 decimal places just so that when I do my work, ideally it won't affect my final answer because I know the level I'm rounding to. But if I would have only worked here, if I'd have worked to 3 sig figs and worked to 3 sig figs and used these to do calculations, it will mess up my final answer a little bit. So that's why I'm taking these further. Okay. Okay. So I have this point. Coming up here. All right. So I have this point right here. This is my x value, and this is my y value. Obviously, they're not going to fit there, so I'm not even going to try. So the last step is, well, I got to find the distance between this point and this point. So now we just go back to our handy-dandy distance formula. The distance formula between 2 points. And I think I can squeeze it in right here. So the distance formula between 2 points is we take the square root of x sub 2 minus x sub 1, and we square it, and we add it to y sub 2 minus y sub 1, and we square it. Okay? We just plug that in, and we should be fine. All right, so, let's see here. How about we just do the whole thing on our calculator? Let's try that, okay? I'll write it down first, and then we'll put it in the calculator. So we're going to have the square root. We'll do these ones first, okay? Square root of 15, that's my x value, minus 14.5122 squared, plus 16 minus 16.6098 squared. Okay. Let's see if we can just plug this whole thing in here. Let's see if I can make it so you can see it. All right, so I'm just going to kind of copy this all down, and it should work just fine. Let's see what happens here. Square root, boom, 15 minus 14.5122 squared plus, open that parenthesis, 16 minus 16.6098 squared. Okay, hit enter. Voila, we get 0.780. We're going to go to 3 sig figs, so we say 0.781. And that's our answer. We did it. That's the shortest distance. Let's put here 0.781. And I guess there's no units on this question. We say units. Okay. And that's the shortest distance, okay? I know that was a lot of work. It combines a lot of concepts, but that's why it's a solid problem. All right. If you have any questions, leave them in the comments below. And if you want to be notified when more Mathity-Math comes your way, go ahead and subscribe. Thanks. Bye.